Welcome back to Physical Science 101. This is our third lesson of Unit 1. So far, we've been talking about speed, distance, and time. Today, we're going to introduce velocity. What is velocity? Velocity combines both speed and direction of motion. So we would say that velocity is a vector. A vector is a quantity that has both an amount and a direction. Why do we have such a concept? Well, consider your car. Your speed would be, say, 60 miles an hour. That's what your speedometer reads. But your velocity would be 60 miles an hour north, 60 miles an hour east, 60 miles an hour south, or 60 miles an hour west. Those are all the same speed, but those are different velocities, and the direction matters depending on where you want to go. If you're headed in the wrong direction, you won't get where you want to go. So velocity takes into account that both your speed and your direction of motion matter with where you want to go. So this is our first vector quantity that we've encountered. There will be more. For example, force in our next unit is also a vector quantity, and the direction of a force matters as much as the amount of the force. So velocity is the combination of both your speed and your direction of motion. Speed is the amount of velocity, and direction of velocity is the direction. Why is this important? Well, it's important when we come to the concept of acceleration, because acceleration is a change in velocity. Acceleration is a change in velocity. That could be either a change in speed or a change in direction. So acceleration is a change in your velocity, either a change in the speed part of your velocity or in the direction part of your velocity. So when we calculate acceleration, it depends, the way that we calculate acceleration depends on whether we are changing speed or changing direction. If we're changing speed, then we would calculate acceleration as the change in speed over the time over which that change in speed occurred. So we would write that in symbols as A for acceleration. That would be the change in speed. We're going to use this symbol delta. This delta represents change. When you see that delta, that is a Greek letter delta, like you might see on some of your fraternities or sororities. That is a Greek letter delta, not a triangle, a Greek letter delta, and then V for speed. So acceleration is change in speed over time. So that is how we would calculate acceleration. So what are the units of acceleration? Well, the units of speed are meters per second, and then we have another second in the denominator. So the units of this are meters per second times another second in the denominator. So we would write that as meters per second squared. And the units over here would be also meters per second squared. So the units have to match on both sides. So the units of acceleration are meters per second squared, and that is the same as change in speed over change in time. So it'd be meters per second or meters per second squared. So if we have a change in speed, then we would calculate our acceleration as change in speed over change in time. How about a change in direction? Well, think about your car going around a curve. If your car is going around a curve at constant speed, then it is not changing its speed, but it is accelerating because it's changing its direction. So if we have a change in direction, then we would calculate acceleration as the square of the speed divided by the radius of the curve. As your car turns, if you were to keep turning and not straighten up, if you were to keep turning, your car would go in a circle. And the acceleration depends on the radius of the circle that you're making. Now, you don't have to go in a full circle. As long as you're going on an arc of a circle, you can still calculate the radius of that circle. And I'll give you an example of that later. So speed over radius of the circle. Okay? Now the question is, do our units work out? Well, what are our units? Speed squared would be meters squared divided by seconds squared. So speed is meters per second, and so when we square that, we get meters squared per second squared. Now I'm dividing by the radius of the circle, so I'm dividing by a meter. Now that meter in the denominator cancels off one of the meters from the meter squared. So we still have meters per second squared, and so our acceleration is still in meters per second squared. So our SI unit of acceleration is meters per second squared. Okay, let's work out an example of this. So here's a situation for you to analyze and a question for you to answer. What is the acceleration in meters per second squared of a car that accelerates from 0 to 60 miles per hour in 6 seconds? That's how you'll typically hear acceleration quoted in regards to automobiles. So this particular car goes from 0 to 60 miles per hour in 6 seconds. And what we want to know is, what is that acceleration in meters per second squared? So how will you approach this? First, draw your motion diagram, note the measurements, convert the units if necessary, then write the appropriate equation. You have 2 equations for acceleration to choose from, and you have to choose the correct one. And then, and only then, do you start working the math. So let's go through all those steps. If you would like, you can pause here and try and get ahead of me. See what you can do. And then if you get all the way through, that's great. If you get stuck, then you can start the video again and let me catch up with you, and you can see where you have to make some corrections. That way you'll learn. Okay. Our motion diagram is going to look similar to what you've seen before. We have our car. It's 0. Initially, it's 0 miles per hour. Its speed is 0 miles per hour. And finally, its speed is 60 miles per hour. And let's see, what else? The time is 6 seconds, and we want to know what the acceleration is. Okay, so we've drawn our diagram. The car is initially moving with a speed of 0 miles per hour. It has changed to a speed of 60 miles per hour over a time of 6 seconds, and we want to know its acceleration. So we've drawn the motion diagram, we've noted the measurements, we've also noted what we're looking for, and next we have some unit conversions to do. We know that we want the answer in meters per second squared, so we're going to have to change our miles to meters and our hours to seconds. Okay? We do that with our fractions. First, we can change our miles to kilometers. Miles is in the numerator, so I'll put miles in the denominator. And that leaves kilometers in the numerator. And previously we had a conversion factor of 1 mile is 1.609 kilometers. That cancels out our miles. So now we have kilometers per hour. Well, we can change those kilometers to meters. Another fraction, we want to change kilometers to meters. We have kilometers in the numerator, so we want kilometers in the denominator. That leaves meters for the numerator. Now we have to have the same thing on top and bottom. And 1 kilometer is 1,000 meters. Okay, we're getting there. Now that gets rid of our kilometers, and we now have meters per hour. We want to change our hours to seconds. So first we'll change our hours to minutes and our minutes to seconds. So that's 2 conversions. So hours is in the denominator. So hour goes in the numerator to cancel out. Now we have meters per minute. Minutes in the denominator. Minute goes in the numerator. And seconds in the denominator. And 1 hour is 60 minutes. And 1 minute is 60 seconds. And if you want to do that in one step and just say that 1 hour is 3,600 seconds, you can also do that. That will come out the same. So I've canceled out my minutes. And what does this all equal? Okay. We have 60 times 1.609 times 1,000 divided by 60 divided by 60. And that comes out to 26.8. Once again, I'm rounding off to 3 significant figures, and we're left with meters per second. Okay, so that is our final speed. Okay, so now we have everything in SI units, and we have to get the correct starting equation. Well, we have 2 equations for acceleration. Either acceleration, we have acceleration when the speed is changing, and we have acceleration when you're curving. What's going on here? The speed is changing, so we have to use our equation for acceleration when speed is changing. So that is, acceleration is change in speed over time. What is my change in speed? My change in speed is I go from 0 to 26.8. That is a change of 26.8 meters per second. So 26.8 meters per second. And I could even write minus 0 if I wanted to, because that would be the change. It would be my final speed minus my initial speed. So 26.8 minus 0 is 26.8 meters per second. My time is 6 seconds. So that gives me an acceleration of 26.8 divided by 6. That gives me an acceleration of 4.466. So 4.4, the 6 I will round up to 7. 4.47 meters per second or meters per second squared. So that is the answer to the question that you were asked. So once again, go through the whole process, draw your diagram, get all the information out, get your data, draw a diagram, get your data, do unit conversions, then pick the correct equation, and then once you've done all of that, then you start working. Resist the temptation to jump straight to the equation. All of these steps are important if you want to get the correct answer every time. Okay, let me give you another question. You are approaching an interstate exit ramp, and there's a sign that says exit 25 miles an hour. If we look at the exit ramp from above, you can see that it does have the shape of a circle, and using Google Earth, I've measured the radius of that circle to be 60 meters. So the question is, what is the acceleration in meters per second squared of a car traveling at 25 miles an hour around a circle of radius 60 meters? So once again, go ahead and see what you can do with this. Draw your diagram, get all of your information out of it, identify the situation and the correct equation, and work it. You can pause and see what you can do with this, and then when you're ready, just start up again and you can follow along with me. Okay, let's start with our diagram. Here I have the car going around a circle. The radius of the circle is 60 meters. The speed of the car is 25 miles per hour. Which we know we're going to have to convert. So I'm going to convert my miles to kilometers. And 1 mile is 1.609 kilometers. And 1 kilometer is 1,000 meters. And once again, as I said before, if you want to do this in one step and you want to say that 1 mile is 1,609 kilometers, so multiplying this 1.609 by 1,000 gives you 1,609. If you want to do it in one step in the future, that's also appropriate. So you can do a unit conversion from miles straight to meters. 1 mile is 1,609 meters. If you want to do that in the future. And as I said the last time, we can go from hours to seconds in one step. Hours is in the denominator, hour in the numerator, seconds in the denominator, and 1 hour is 60 times 60, or 3,600 seconds. Okay. What is that? 25 times 1.609 times 1,000 divided by 3,600, and that is 11.17, which I'm going to round up to 11.2 meters per second. So the speed of the car is 11.2 meters per second. And the question is, what is the acceleration? So we have completely modeled the situation, okay, and we've gotten all of our data. We have the car moving at a speed of 11.2 meters per second around a curve of radius 60 meters, and we want to know its acceleration. Once again, we have two equations for acceleration depending on the situation. The situation here is that it's curving. So when you are curving, our equation is acceleration is speed squared over the radius. So now we have completely modeled the situation. We're ready to solve it. Acceleration, speed squared, that would be 11.2 meters per second squared over 60 meters. So the acceleration in this case is 11.2 squared divided by 60. That would be 2.09 meters squared per second squared per meter, or meters per second squared. Okay, and that is the answer to that question. So as that car goes around the curve, it is accelerating at 2.09 meters per second squared. Now I have a couple of multiple choice questions for you. The first is, acceleration occurs when an object undergoes A, a speed increase, B, a speed decrease, C, a change in the direction of travel, or D, any of the above. Now please take a moment and come down definitively on one of these answers before you continue. So think about it, and it's very important that you think through these questions and come to the answer that you think is correct. So you can pause and take a moment to think about it and definitively come down on one answer or another. Okay, acceleration, remember, is the change in an object's velocity. Acceleration is the change in an object's velocity. Velocity is both speed and direction. So acceleration occurs when speed changes or when direction changes. So acceleration occurs when an object undergoes a speed increase. That is correct, because an increase in speed is a change in speed. Acceleration occurs when an object undergoes a speed decrease. That's also correct, because a decrease in speed is a change in speed. So those two are changes in speed, so those are acceleration. Acceleration occurs when an object undergoes a change in the direction of travel. That's also correct, because acceleration is a change in velocity, which is a change in speed, or a change in direction. So acceleration occurs when all three of those happen, or any of those three happen. So the correct answer is D. Acceleration occurs when an object undergoes any of the above. Okay, here's another question. An automobile has how many different controls that can cause it to undergo acceleration? None, 1, 2, or 3 or more. So once again, pause, take a moment, and think about this. Pause and think, and come down definitively on one answer. It's very important. It's very important that you pause and think about what your answer is, because you're going to learn by thinking about it and then hearing the answer. If you were correct, that's great. You understood it. If you were wrong, you have something to learn, and you've learned something, so that's great as well. So pause, come down and think about it. Pause, think about your answer, and then come back. Okay, remember, what is acceleration? Acceleration is a change in speed, so an increase or decrease in speed, or a change in direction. So how many controls do you have in the automobile that can cause it to increase speed, decrease speed, or change its direction? Well, you have the accelerator. That will cause your car to speed up. That's an acceleration. Your brake will cause your speed to decrease. So that's two controls that will cause your speed to change, either the accelerator pedal or the brake pedal. However, your steering wheel will also cause your car to accelerate by changing its direction. So a change in direction is a change in velocity, which is acceleration. So you have at least 3 controls in your car that will cause your car to undergo acceleration: the accelerator pedal, the brake pedal, and the steering wheel. All of those will change your car's velocity, meaning it will change your car's speed, or it will change your car's direction. So the correct answer here is D, 3 or more. Okay, that is the end of today's lesson, and we'll have one more lesson before we're done with Unit 1. So until then, think science.